freezing point at freezing point of a solvent, it is liquid state at freezing point, the solvent and it is liquid state are in equilibrium. At freezing point, at the freezing point, the solvent, if we take the freezing point of a solvent, then at freezing point the solvent and its liquid state, their vapor pressure, they are in equilibrium. That means they have the same vapor pressure. Freezing point may be defined as the temperature at which solid and the liquid state of a substance have the same vapor pressure. When a non-volatile solute is added to the solvent to form the solution, vapor pressure gets lowered. So vapor pressure of a solution is less than that of the pure solvent. This will be explained graphically. That this is the vapor pressure curve of the solvent, pure solvent. That BC is the vapor pressure curve of the pure solvent, and this is the vapor pressure curve of the solution. That this is the vapor pressure curve of the frozen solvent, that it is dE. So when we know that the vapor pressure of this pure solvent curve, this meets the frozen solvent curve at x. X corresponds to the temperature, let it is T omicron F, and the vapor pressure curve of the solution meets the vapor pressure curve of the solvent at Tf, let Fy corresponds to the temperature Tf. So these two, now there is a difference. This difference is the depression in freezing point. So we know that del Tf is equal to, since T omicron F is greater, T omicron F minus Tf. I will try it again. Bc is the vapor pressure curve of the pure solvent, and De is the vapor pressure curve of the solution. Let this is Gf is the vapor pressure curve of the frozen solvent. We know the vapor pressure curve of the pure solvent meets the solid curve at x. X corresponds to the temperature T omicron F, and vapor pressure curve of the solution meets the solid curve at y, which corresponds to Tf. Since Tf is greater than Tf, therefore del Tf is T omicron F minus Tf. This difference in the freezing points is called depression in freezing point. We know that del Tf is proportional to m, where m is the molarity of the solution. So since molarity is the number of moles, molarity is the number of moles dissolved per kg of the solvent. Here we take the number of moles into consideration. Therefore, depression in freezing point is a colligative property. Now del Tf, we know del Tf is proportional to m, or del Tf is equal to, that is Kf into m. Kf is the constant of proportionality known as molar depression freezing point constant, or it is called cryoscopic constant. If molarity of the solution is 1, then del Tf is equal to Kf. Therefore, molar depression freezing point constant or cryoscopic constant is the depression in freezing point of, when we consider the molarity of solution as 1, therefore del Tf becomes equal to Kf. Therefore, molar depression freezing point constant is defined as depression in freezing point of 1 molar solution. Now let us determine the molecular mass of the solute from this solution, from this equation. We know del Tf is equal to Kfm. Let us determine the molecular mass of solute from this equation. We know del Tf is equal to Kf. Molarity is defined as number of moles of solute dissolved per kg of the solvent, weight of solvent into 1000. If we take weight of solvent in grams, then we have multiply into 1000. Therefore, it will be equal to Kf number of moles. If we take Wb grams of solute, let m be the molecular mass of solute, let Wa is the weight of solvent. Therefore, we get del Tf is equal to, we know number of moles is equal to mass of the solute divided by molecular mass. Then it is del Tf is Wb divided by Mb, number of moles, into weight of solvent. It is Wa into 1000. This becomes the equation. Del Tf is equal to Kf into Wb divided by Mb into 1000 divided by Wa. Therefore, Mb is equal to Kf into Wb into 1000 divided by del Tf into Wa. Therefore, molecular mass of the solute can be determined. Kf can be determined by the separate equation, that is mr Tf square divided by del H fusion into 1000. By this equation, we can calculate the Kf, that is the molar depression freezing point constant. It is molecular mass into gas constant del H fusion into 1000. By this equation, the value for water comes 1.86 Kelvin per mole. This comes the value for water. This is how we calculate the molar mass of solute from the depression in freezing point.